at obviously Organic 2. I'm going to talk about the syllabus. I'm going to talk about the expectations. I'm going to talk about why this is different to the first semester, why you can't just expect to do as well this term as you did last term because using the same amount of input and effort. It is a very different semester. It's a very different set of skills that you need to come up with this semester. So what we're going to do is work our way through the reasons why you're here, think about where you need to be in the future, and talk about stuff that maybe you don't get to talk about in other classes, things like CVs, a resume, taking the next step, getting an internship, getting into a graduate program, things that you need to worry about in the future. We'll try and push along to you so that you're aware of what's going to happen there. So why are we here? Including the chemical engineers, why are we here? For many of us, we have to understand the basics of carbon chemistry so we can understand the basics of biochemistry and then worry about things like biological engineering and stuff like that. So each of you think about your major, think about your minor. Chemically based, we've got to worry about the structures of carbon, which we've done a little bit last semester, and then start thinking about why carbon has been, why is it the sort of basis of life and why do we see so much of it? So if you look at the slide there, you'll see a couple of pictures at the bottom, a couple of diagrams, and that's trying to indicate that the second semester is bigger. The molecules get bigger, the reaction mechanisms get bigger, all right? You can see if you take biochemistry, the reaction mechanisms get horrendously big. So we are taking steps to get to that place and that point where people will be comfortable. And I just choose these two materials at the bottom because they are indicative of where we need to be in the next 15 weeks, but also why organic chemistry to me is fascinating. On the left, you have a protein. Okay, and a protein is made up of amino acids and they're linked together by amide bonds. We'll spend a lot of time at the end of this semester talking about amides and how they're used in proteins. And that's a very delicate structure that's used in biology to maybe catalyze something. It's the equivalent maybe of H+, something like that. And on the right, we have a molecule that is synthetic. It's made in the lab. It has the same type of bonds bonding the material together. But this is Kevlar, right? You can imagine now the properties that Kevlar has in terms of being able to stop shrapnel and stuff like that. It's a very hard material, but held together by the same chemical bonds as the protein on the left. So the job in this semester is to get to appreciate that so we can take it with us into bigger subjects that you'll see in the future. So what we'll do today is spend most of our time thinking about where we need to be, what your responsibilities are, what I can offer you to help. And since, you can see there's a lot of space in this room now. The first day of last semester, it was pretty crowded. Now the people at the back, you can sit in 3 different seats if you want, instead of being right next to each other. You'll find that 3720 is a natural continuation of 3719, but with a different expectation level, right? You've all made it through. You are the survivors. You made it through the first round. And now you have to try and make it through the second round to be able to go further. This is more interesting, I think. This is my favorite semester because, number one, we're heading towards the summer, but also because the material is just that more interesting. Less nomenclature, less memorization stuff, and more chemistry and more thinking about things that you can pick up and use in a proactive sense. Now, I always do this in my first class, in my first day, just to make sure that we're aware of the parameters, we're aware of the statistics, nothing's hidden here. We will tell you that a year ago, in fall 2013, 140 people began. This room is very crowded, and 85 people get through. That was pretty much the same last semester. Okay, that was pretty much the same last semester. I put it down to the fact that at 18, 19 years old, people who don't get through this class typically aren't good students. Not because they're not smart, it's because they don't know how to be disciplined and they don't know how to get this thing done. Right? You lot made it through, so you have some of that self-discipline, and hopefully it starts to pay off now. In the second semester, 1 year ago, the class started out with 83. I have exactly that number in here today, or should have, and only 68 people got through. Now, that's not too bad. Right? That means that most of you will get through if you put the time in and you put the effort in. Right? It's Newton's third law. You get out what you put in type of idea. It really is. The people who don't get through typically were weak in the first semester or didn't get any help. They didn't learn that the help is available from myself, from Cole, from anybody else who's interested in organic chemistry, particularly over at CSP. So what that boils down to is that only half of the people who start the first organic class get through the 2 organic classes in one go. So you can think of that in several ways. If you get through both of them, well done, right? It's unusual, or you're in the top half there. But the other 50%, where are they? What are they doing? Some of them drop out of school. Some of them end up taking this class 5 times. I mean, I like organic chemistry, but I wouldn't want to take it 5 times. That's just a bit silly. But what we need to do here is to understand from day one that the expectation level is higher now, and it will be demanding, and you will be pushed. So we start thinking about things like how to fix this, right? The fact that only 50% get through isn't a good thing. So how do we fix that? And some of you have seen this. I have some people in here who haven't seen me for a while. I haven't had this new book. We were using the homework. We are using Wiley Plus again. If you're not aware of this, if this is different or new to you, email me, come and see me, ask me, and see how you get involved with this. We sort of took away the pressure of all of the exams by including some homework. You can work on these ideas over the break. over the semester, and that goes into your grade. It's not all about exams these days, and this worked out quite well last semester. And what I found was that the people who are doing well do better, right? That's a big problem. The people who are doing well do better, and those who are struggling still struggle. And I still think that comes down a lot to discipline and not being able to sort of put it all together. So that's still going to be included. It's on the syllabus there. I'll talk through the syllabus in a minute, and we need to think about other things. I have updated my webpage over the break. There's a bunch of stuff there that will help you with 3720. That's what it looks like. That's the URL. That should be bookmarked on everything that you look at the internet on. And then we can talk about things that I put together to try and help. Models help. I put together 3D things. I put together some videos and some movies to try and help you get through these concepts. I still have the mechanism page. There's 120 mechanisms in the class. There's 120, I think, mechanism videos there. Just 3-minute looks at what the mechanism covers. If it's, some people learn differently. If you can look at the video and look at the pictures, maybe that helps instead of just trying to memorize it. Hopefully that picks up and helps. There will be a lot of practice material there. We'll work our way through to the spectroscopy sections in the first part of the semester. That stuff is very difficult, and that really tests people. So I put a lot of stuff on there to practice, and that's stuff that I'll point out as we go along. So I think what we're trying to do now is to become a bit more modern. You can see people using tablets. You can see people with their laptops out. Hopefully they're not watching movies. They're watching something organic chemical. And you can start to use those things to take notes. And we've got the online textbook comes with the Wiley Plus, so maybe you don't need to buy a physical book. The practice problems I've developed all work on the phone and the iPad and stuff like that. So hopefully now you've got more mobile things to look at so that you're not wasting time, right? You're a very difficult, very important part in your educational experiences. The sophomore/junior year sets everything else up. You think about applications for professional school or for graduate school or for jobs, it's all happening now, all right? So this is a really important semester coming up. I always put this slide up to make sure that people recognize why we're here. It's not just to fill in a credit sheet. It's not just a check in a box to get you a degree. It's the foundation of something else, right? You can't do biochemistry without knowing anything about organic chemistry. And for those of you who are interested in engineering and stuff like that, material science is based a lot on carbon chemistry. Forensics is based on tests that are based on biological chemistry. So you really have to be okay with this stuff. Are you ever going to be required to memorize and regurgitate a mechanism in the future? Probably not. If you go into forensic science, you'll never see a mechanism again. But the processes that were required there to get to that level, the understanding and the dedication, and I keep using this word discipline to get that done, is going to become apparent in the future. In terms of who's involved, I've got some, I don't know why your picture came out weird, Chris, but it did. We got TAs in the lab, we got Chris, we got Cephas, and Emmanuel has joined the team this year. You'll be in lab. Lab is running this week. You do need to go to lab this week to check in, okay? Make sure you go to lab this week to check in. In terms of, most of you know who I am. I always do this again just to make sure we're on the same page. Just because I have this marvelous accent doesn't mean I'm royalty or anything like that. I was born in Liverpool, which is not a nice place. My parents, my grandparents worked in coal mines and factories. My parents went to school and became teachers, and I became a professor. So education is very important to us because it helped us get away from fairly meager circumstances. I went to Ohio State for a Ph.D., so do not dare try to contact me this evening. Right, between 8:30 and the time I wake up tomorrow, do not try to contact me, right? If it goes as planned and it goes to the fourth quarter, I will not be in early tomorrow. Do not try and find me before lunchtime tomorrow, right? If it's a blowout by halftime, I'll be in at 9. Okay, so that's where we're at. I'm a very busy person, but I do like science, I think, and I do try to communicate not just the science itself, but what you can do with science. I'm very keen on helping people get where they want to go, so make sure you understand that. My office hours, as you see on the syllabus, I have to put down some office hours. I have to give numbers, I have to give times. But I think those of you who took advantage of office hours last semester found that if I'm not busy, I'll talk to you whenever, right? That's, I think, important. I think it's important people have jobs, they have families, they have other obligations, they have busy schedules. I just like science, I like chemistry, I like talking about it. So if you want to come to office hours whenever you want, please do so. Obviously better if you give me a heads up. There's my contact information for those of you that don't have it. Email is easy. My phone still works. I think I put it back in the wall after I ignored it for most of the summer. And there's the web address. So all of that will be useful, and make sure we're okay with the contact information. Now, again, just to try and get over this barrier, you at some point are going to have to ask people for things. You are going to have to ask, and I'm looking at people who don't really care about this, or why should I go to office hours? You're going to have to ask for letter of recommendation if you want to work. Now, some of you might have the luxury of being here and not having to work in the future. Most of us don't have that luxury. But you will need letter of recommendation for job applications. I get people in from the FBI. I get people in from the federal government asking me for applications for people who took my class. I write dozens and dozens and dozens of letters of recommendation for people who want to go to graduate school, pharmacy school, medical school, job. So you're not going to get those letters unless you actually talk to people. Now, you might say, well, you know, maybe my priest will write me a letter, or maybe the guy I worked with at Burger King will write me a letter. No. Academic letters are really important. So your job is to try and get to know who people are. Here's the deal. I'm busy. I like being busy. I like going home and feeling really tired and going to sleep because it feels good that you got something done. Find me, ask me questions, start to think about what comes next. This is not just organic chemistry, this is setting up what comes next. I will not write letters of recommendation for people who I don't know. But I was in your class. I don't care. I don't know who you are. If all I know about you is a grade, John Boy got an A in my class. Sincerely, Peter Norris. That's it. Right? But if I know who you are, if I've got some indication of your, I don't know, maturity level, your organization level, I've got some idea of what you want to do and why you want to do it, and I'm speaking not just for myself, but for other professors, we'll help you out. Right? We will help you out. We spend a lot of time doing this, but it works out. People get where they want to go if they're mature about it. So just to prove that I'm not mean, there's my dog. I mean, that lives with us. That lives in my house. Chachko, you're shaking your head. I wanted a dog, she wanted a cat, we ended up with that. Okay? But that's how intimidating I am. So get over it and start interacting, start engaging and help yourselves out. Now, so far, you know, we've learned a bit about organic chemistry. It's actually your third year of chemistry, you think about it, high school, freshman level, organic chemistry. You should know a lot by now. And if you're in this class, the expectation is you do know a lot by now. We're not going to go back and do any remedial stuff. Everything that was in 3719 is still game. The SN1, the SN2, the E2, molecular rearrangements, all those things, you need to be on top of that stuff. So now you need to bring it with you, because in the second semester we start playing the game. The mechanisms get bigger, they probably get more interesting because we can apply them now to biological systems and interesting concepts like spectroscopy, in which we can work out why things happen and how do we know things happen. Everything I've said so far, most of you have just sat there and go, okay, yeah, you know, you're the guy with the gray hair, so you must know what you're talking about. Well, we have to prove it. The whole point about science is to prove things. So this semester we'll start proving things with spectroscopy and ideas like that, and we'll understand where mechanism comes from and understand why this stuff is so powerful and so useful. Now, and this is mainly for people who don't know me or are coming back to this after a while, what is my philosophy in teaching? What do I think about? Well, I have no teacher training whatsoever. I never took an education class in my life. I don't have a license, right? Apparently, if you get a Ph.D., you're supposed to do anything, right? So this is what we're going to do. I cannot memorize that. That's Taxol. That's a very important anti-cancer drug that's very useful for soft tissue cancers. Very expensive. It's been made in the lab. It's found on various trees throughout the Pacific Northwest. It's a very important compound. Can you memorize that? No, neither can I, because I don't need to. The way I was taught, again by people who have no teaching experience whatsoever, is to think about the material in terms of breaking it down into small problems. Knowing some basic concepts, knowing the chess moves like we developed last semester, knowing that the knight goes up and across one, up two and across one, knowing that the castle goes left and right and up and down, knowing what the parameters are, so that when you put them all together, you can play the game. No, you're not going to memorize that, but you might see that. In fact, we probably saw something like this on one of the exams last semester when I asked you about RNS, all about that configuration and stuff. And all of those who got through here were not intimidated by that. You looked at it and went, okay, organic molecule, big whoop. And you started to dissect the problem and work it out. And that's what you need in the future. So the critical thinking idea. Understand some basic principles and then put it together. So we need to think about, okay, we can disassemble this thing, work backwards and think about, all right, I know that phenyl rings are flat. They're all sp2 hybridized. I know that alcohols are polar because it has an OH group there, which is a delta plus delta minus situation. We know the small ring might pop open, which might have something to do with its biological efficacy. What's the mechanism of its interaction with a biological system? And this semester, we'll learn about the rest of it. So that's my approach. You pick things up in a gradual way, in a consistent manner, by learning consistently and not just leaving it to the day before the test, and you should do very well. So here we go. Be proactive, big word. Get on this as soon as you possibly can. Class started today. If you've been seeing my emails over the break, class actually started the day after the final last semester. Right? And I know some people are already 4 chapters into the textbook for the second term. That's competition. And for those of you who want to be physicians, those of you who want to drive those fancy cars that keep cutting me off on the highway, you need to be in the A range with everything, right? You're not going to get to med school with B's and C's. or pharmacy school. You need to be up there. So you need to start doing this and taking care of what you need to do to get to where you want. Okay. The syllabus in front of you, it's a white piece of paper with some black writing on it. It basically is a contract. This is what I'm going to deliver to you, and your job is to actually put something into it, put something back. This is not a ticket to a ride, right? This is a contract. This says if you do what you should be doing and put it right the level of effort in, you should pass this class with no problem whatsoever. You might even enjoy it. Imagine that. We're still using the same textbook. If you're coming back to this class after a while and you have the first edition, that's fine, right? But you will need Wiley Plus. I'm going to talk about the homework in a second for the new people. For those of you who have already been in here, it's the same thing, and it's even a continuation of last term. You should be able to log into Wiley Plus and you'll see the new assignments. The objectives. My objective as an organic chemist is to get you to understand a bit more about organic chemistry. My objective as a professor and somebody who cares about what we're doing here is to get you to a point where you're competitive in the future, be it in biochem class or P-Chem or quantitative analysis or anything else. You're getting to a point where you're disciplined enough, on top of being smart enough, that's not enough anymore, being disciplined enough to get to that level, to compete. Because when you're coming out of Youngstown State, there's a big world out there, right? You know, we always say that YSU is the best university in the Mahoning Valley. It is. Right? But once you get out of the Mahoning Valley, it's very, very, very competitive. So we need to make you competitive. All right, so the objectives are to make you competitive and to help you learn stuff. Now, the whole point of organic chemistry, as we've said, you can read this if you'd like. It's just a bit of material we're obliged to put in there, talking about why carbon is so important. Think about why carbon is, why do we choose carbon? Why is carbon a whole year of focus for you? And if you take biochem, another year of focus. Well, think about what it can form. Single bonds, double bonds, triple bonds. It can form plus charges, radicals. This semester it will form negative charges, more so than last semester. It's very versatile. All based on the fact that its electronegativity is what? Don't get this wrong, Pierce. What's the electronegativity of carbon? 2.5, shoots and scores. Yes, it is, right? It's middle. It's middle. So it can form all these different bonds to all these different elements. And it turns out carbon can form more bonds than all the other elements put together. It's just amazing in terms of versatility. So have a look at that stuff. Excuse me. And you're advised to be in the recitation section. If you're not in the recitation section, you are kind of flying without any sort of undercarriage. Yeah, you're kind of flying and you're just flying around and the wheels aren't going to come down. You're on your own. If you're not in recitation, ask yourself why. If you can't afford it, okay. If you don't want to be in it, you don't have time, office hours. Or SI, but make sure it's not all just SI because Cole won't write your letter recommendation. Okay? Make sure you're using as much as you possibly can to do well here. In terms of the assessment, things again we have to go through. Same scheme, 700 points. Lab, make sure you take lab seriously. You have to get at least a 70. This to avoid people blowing it off. Unlike some of the bigger schools, we like to have lab in the same semester as the lecture, so it means something. You're not taking them 2 years apart, so it's pointless. You're taking it at the same time. Your lab grade counts. For many people, it's the difference between a C and a D. Make sure you do the lab, make sure you do it well. You do have lab this week, make sure you show up and check in. Other things, exams, the schedule is there. I hope I haven't given an exam on, I don't know, some day that we're not supposed to be here, like spring break. Make sure you check this with your schedules and your calendars and make sure that we're okay with those exams. Again, there will be 3 semester exams worth 100 points each, typically on a Friday. And then there'll be the final in finals week worth 200 points, and it will be comprehensive. And comprehensive means 3719 and 3720. Yeah, like that, right? Yeah, okay, here we go. Grading is going to be the same, 90, 80, 60 type of deal as it was last semester. If you're not happy with that, ask me why. And hopefully most of you who are here will take it seriously and will do well. Ton of stuff online, ton of stuff in person. I don't know if there's any other class that you'll get more possibilities in terms of help. Right, all this stuff here, if you want to do honors, we can talk about that. If you need to take it incomplete later on, understand the rules. Disability services, contact them if you need extra help. And then academic misconduct, if you cheat, I will destroy you. I will destroy you. So don't. Okay, easy enough. All right, there's my office hours in terms of what's supposed to be on the schedule. Again, find me whenever you can, and we'll talk. Now, what do you need? You need a book. You need access to Wiley if you're going to get this 100 points. If you're coming back to this after a while, you don't want the 100 points, fine. I'll take you a grade off the exams, that's fine. But the 100 points seems to be a popular thing because you can work at it as you work through it, right? So make sure you're okay with that. Make sure if you're not understanding that, ask me questions. You need a web browser which is up to date. You need to make sure that Java is working. so that we can use Wiley Plus. I actually put onto the assignments chapter 13, what was it called? It was a mechanism, I forget what it was. It was the thing that you practiced to make sure that your browser was working. Yeah, I put it on there for chapter 12, so just run through that. It's not graded, and just make sure the things are working, right? Have a go at that, make sure everything's up to date, and we should be good. In terms of Wiley Plus, I've already put the first assignment out for chapter 13. We'll be through that by next week. The actual due date is a week on Saturday, so that's plenty of time to get it done, and we will start motoring pretty quickly now. What do you need to do to get through? Well, a whole bunch of things. Read ahead. Yeah? This is not advice. This is an order. And I'm speaking from experience. I wasn't a very good student. My first couple of years of college, other things to do. Yeah? My second year of college, 19 years old. Paid by the British government to spend a year in America. What? Outrageous. What am I going to do? Study? Right. Well, that came back and bit me later. So make sure you're keeping up. Come to class. Pay attention. Ask questions. I think we're fairly okay now with the idea that I like to ask questions and answer questions, so make sure that you are on top of that. Don't be shy. Sign up for SI. Do the problems in the book. Do Orion. We did see over the break that those who were doing the Orion problems had a deeper understanding of the material. That will pay off this semester. If you're not doing Orion, again, you're flying with one wheel. Do what's advised. Use office hours as often as possible, and if you do all that, you should do well. People should be looking at B's and A's in this class, not just scraping through with a C. Now, in terms of recitation, I'm running the recitations. Dr. Jenner has his first solo class this semester, so we decided he can teach the 3719 recitation again with Dr. Jackson instead of prepping for a new one. I've taught this many, many times, so I'm teaching all the recitations. And I'm not just going to teach. I'm not just going to stand there and talk. It's going to be backwards and forwards. We put our foot down this time and we said we will not have recitations anymore with 70 people in them. That's stupid, right? That doesn't mean anything. So the recitation maximum now is 35. That means we can actually get to talk and actually can converse and learn some things. So if you're in recitation, it should be more fun. We have 3 of them. We decided to add a 3rd one so we could break the class into smaller sections and get more done. So make sure you're in there. If you're not, you pretty much have to have a really good excuse why you're not in there. Okay, usual stuff. Okay, phones, kill them. Don't text. I'll just give you an F, right? Don't play with it. We all know that by now. If you want to get a real job in the future, make sure you get to know who we are. Know what a CV is. Know that you should have one. In terms of not just myself, and what I say to you on this topic is often stuff distilled from people like Dr. Cooper, Dr. Walker, from biology, who have the same mentality. You must know who we are. We must know who you are, to give you a solid reference. Okay? Ask advice as soon as possible. We actually enjoy that stuff. It's nice to see people do well. And in terms of proactive, it's all on you, right? As much as you possibly can. Get involved. Join societies if you need to. Get to know who people are. And hopefully things start to go in your favor. Now, in terms of the website, we already did that. It's all out there. Once you look at that, look at the courses page. Syllabi are there. Lab materials there. Everything you need should be there. Does anybody have any questions so far? Is everybody excited to be here? Brooke, just say yes. Okay, yes you are. Good. Let's get going. All right, so once we got that out of the way, we start to think about what the second semester is about. It is all about building and going somewhere else. We started off on the first term talking about structure, talking about SP3, SP2, talking about shape, trigonal, planar, linear. Those things are now the basic vocabulary of the subject. So we now have to start moving further and start going to what I have on the right. And this is somewhat facetious, but it's true. On the left is chemistry. You can see a molecule. On the right is biology. It's bubblegum. Right? It's all motifs. It's all little structures that are used to exemplify big organic molecules. The little blue bubbles coming off the cell surface, they're carbohydrates, they're polysaccharides. They're important for things like cancer metastasis. They're important for cell-cell communication and embryonic development, stuff like that. We don't have the ability, or we really can't digest all that information if you put all the carbons in there and all the material in there. So one of the big things this semester is going from seeing every single atom to seeing motifs and seeing structures that then can be used to actually express chemical information, but using biological motifs. So I always try and put this in context. 200 years ago, 215 years ago, organic chemistry was first defined. Within 20 years there, the name was made a nonsense because organic used to mean only animals or plants could make these chemicals. Now we can make them in the lab. So now I call this molecular engineering, and in 2015, we can use this material to make new stuff. At the end of this class, you'll be able to make new materials. That's a big difference. So we started off there. Urea, what was the shape of urea? sp2, flat, right? What was the hybridization around nitrogen? What's the hybridization at nitrogen approximately? sp3, the way it's drawn. What's missing from nitrogen that ought to be there to explain its chemistry? A lone pair, right? So we need to understand these things. That was first semester. This is second semester. An awful lot more in terms of molecular architecture, in terms of molecular engineering and putting these things together. So there's a lot to be done. Fair enough? Now, if you brought a pencil with you, get it out. Let's have a look at the beginning of chapter 13. We left off with synthesis. And in recitation, which starts today at 12 o'clock, we're going to go back and look at some of the basics from last term to make sure we're happy with those ideas. Talk about synthesis and talk about putting things together. What we'll do this term is spend quite a bit of time going through different families of molecules. We'll talk about alcohols and phenols first, then we'll talk about ethers and thiols and things like that. And we'll complete the set of the types of molecular structure that you need to worry about to do biochem or to do material science, stuff like that. I'm going to start off with alcohols. And again, I think what we said last semester is that alcohols and alkenes are very central to what we do here. If you have access to an alcohol, you can go all over the place. You can make ethers, you can make alkenes, you can make bromides, things like that. They're very versatile intermediates to be able to do organic synthesis. So what we'll start off with now is a fairly dense chapter. This chapter has 96 slides. That's quite a lot for a chapter. And I'm guessing it takes me 2 weeks to do this. It's a good place to start because it's familiar. You've seen some of it before. And it's a good place to get back into the speed of things as we come off the break. So where do alcohols show up? Everywhere. Right? You cannot get away from these things. And they're usually quite complicated in nature. On the left, you've got grandisol, which is a pheromone. You see that, and it's a certain type of alcohol. We talked about this a little bit. If your OH group is attached to a carbon with one carbon attached, what type is it? What's the word we use for that? Primary. If it's attached to a carbon with two carbons attached, what is it then? Secondary. So what type is this one right here? Secondary. What type is that one right there? Primary, right? So chloramphenicol, which is an antibiotic, has two different alcohols which have different properties. They have different environments. And we'll talk about crowding again. And we'll talk about the requirements of materials to be turned into something more useful and more maybe complicated. And it will rely upon you understanding the difference between primary and secondary and tertiary alcohols. Tertiary alcohols won't do chemistry that primary alcohols will do. So we're going to really develop sort of deep ideas here. What type of alcohol is that in geraniol? That's primary. And if you think about this system here with a pi bond next to a functional group, what was that called last semester? Allylic. Allylic, right? So that will make a difference in terms of its chemistry. We'll see that again. Down here we have cholesterol. And by the end of this semester, we'll biosynthesize cholesterol, show you where it comes from in a very elegant pathway, which is very complicated, but basic organic chemistry. And we will see here that cholesterol has a secondary alcohol. And it has all of this. Now, you think about physical properties. Do you think cholesterol will dissolve in water? No, why not? It's hydrophobic, which is a great word, and it basically is more hydrophobic, it's more non-polar than it is polar, right? So the non-polar bit will win, and that thing will not dissolve up. Do you think it will dissolve in hexane? Quite possibly, right? Because that's a non-polar solvent with a non-polar material. They should dissolve because like dissolve like. As you head over to here, I have no idea how to say that, so I'm not going to even try. Vitamin D3 sounds easier. You have an alcohol on this side and a whole bunch of greasy stuff over there. So we'll now again talk about physical properties, talk about chemical properties based on the simpler motifs that you saw last semester. So you know some of this stuff. We're just showing you some examples of where these things show up. In terms of phenols, which is the other major emphasis for this chapter, what is the approximate pKa of that proton? Be careful. 10. And you cannot forget pKa's, right? If you're bored this afternoon, wait for the game to start tonight, learn your pKa's. Okay? So that's 10. Why is it 10 and not 16? It will be resonance stabilized when you take it off and make a negative charge. The benzene ring will have something to say about the stability of the negative charge. So we can see here all kinds of possibilities here. Some really interesting compounds. Capsaicin, chili peppers, if you like hot chili peppers or wings and stuff like that. That's one of the things in there that makes the things really hot. It's a phenol right there. And some of you probably know about this stuff. This is THC, and you can see the phenol right there. It has a hydroxyl. Again, it's a pH of about 10, and it's all based on this submotif of the phenol. And all kinds of different subjects that seem to have interesting properties. Dopamine, right? One of these neurotransmitters that people are really interested in these days. That has two OH groups, right? So it's a diphenol. So again, we're going to build up structure. We're going to build up ideas of how what these things look like, so that over the next couple of days, next couple of weeks, we can start to understand their chemistry. In terms of other structures that we'll have to work on and bringing things with you from last term, you can look at that molecule and you can point out chiral centers. How many chiral centers in that system? 6. And are they R or S? The point is, you'd have to work it out. And my point is that you should be able to work it out, right? So, you know, we've had 4 weeks off, which is way too long for a break, but it does tend to sort of, you forget things. Go back and learn how to do RNS. And you can see here that this, you know, testosterone has the secondary alcohol up here, and then down here, myoinositol, which is a structure for building off of carbohydrates, has 6 different OH groups. Now, what's the pK approximately of that one? 16. It does not have the benzene ring. It's not going to be 10. So things you need to bring with you. So again, the point is that alcohols are ubiquitous. They're very important materials that we can get a lot of in terms of size and bulk from nature, and they're very useful for synthesis. I want to get this out of the way now, because nomenclature is pretty straightforward, and we get it done now. We can start the actual mechanisms on Wednesday. We need to know how to name these things. And we use the same type of procedure that we used last year. We look for longest chains, we look for biggest cycles, things like that, and use that as the parent. And you can see here that if we have a pentanol like this, we're looking at the OH group now being the functional group, and then we look at the carbons. You don't count the OH group, it's 1, 2, 3, 4, 5. So pentanol. Now, is pentanol enough? Knowing what you know from last year, is pentanol enough for you to be able to communicate safely and get a bottle of pentanol? You went to the shop and asked for a bottle of pentanol. Is there enough information in that name? There is not. Why not? You need a number. Is that right? You need a number. Because if I put the OH group here, what does it become? 2-pentanol. Or here, 3-pentanol. So don't forget the numbers are important in terms of isomers and differentiating one isomer from another. So in this case, this would be what? 1-pentanol, right? Okay, that's good. In terms of OH being important, I've said this often, OH groups are very important chemically and very important in terms of the hierarchy of how to name organic structures. So we can see here that even though this molecule has a long chain, 1, 2, 3, 4, 5, 6, 7, 8, that does not include the hydroxyl. So you must include the hydroxyl, and then everything else becomes a substituent. So in this case, what would this substituent be? Propyl, right? Propyl. And which carbon is it at? 2. So if I name this 1, this would then be 2-propyl, 1-hexanol. So be careful. Just follow the rules, and there's nothing too tricky about this. Numbering, the OH is important. The OH rules. So in this case, if I label from the left, the OH could be a 2. If I label from the right, it could be a 6. OH wins. So OH is 2, gets the smaller number. And then down here, a little sort of artifact from the past. I think this is a North American versus European thing, as usual. Where do you put the number? Okay, you can put the number at the front, 3-pentanol, that's fine. And if you're from somewhere else, you can put the number in the middle, pentantriol, that's fine. Both are okay. That's why organic chemistry can be a bit annoying and a bit confusing, because it developed all over the world, and now we're trying to distill down to the best practices throughout the subject, but both of these are okay, both of them work. What does the 3 tell you? Where the alcohol is, okay? Same stuff as last year. Okay, some names. Some names here. Looking at the top, you will still see questions on the first exam that ask you to name something. And you'll be asked to include stereochemical descriptors. And what that means is EOZ or RNS. So we need to be on top of that. In this case, why do I need R? What does R tell me? The stereochemistry of this carbon right here, right? And that R is at the front. There's only one stereocenter, so you don't need to label it 2 or 3. There's only one of them. And then we have the chloro here, and the phenyl. We'll talk a lot about benzene chemistry in the near future. We'll understand a lot more about that type of idea. But again here, the OH group is winning. At the front, the number goes there to say 1-propanol. Down here, why no number? Why isn't there a number? It does not matter. If I put the OH group at the top or the bottom or the left or the right, it is still cyclopentanol. I will need a number if I have another substituent or substituents. And you can see now how important the OH group is. It's the top of the hierarchy that we've developed so far. it by default is number 1. So if it's by default number 1, you don't have to give it a number in the name. So in this case, we can see R is the stereochemical configuration right there, and then 3,3-dimethyl is over here. It's not an isopropyl group, it's 2 methyl groups, and then cyclopentanol, you don't need a number because by default the OH group is at 1. Easy enough? Okay, so move on. I'm going to get this stuff out of the way so that Wednesday we can crack into mechanism. The definition we sort of developed with those pictures a little bit earlier looks like this. We have different types of alcohol, and they will do different chemistry depending upon what type they are. That complicates things. We can see on the left a primary alcohol. So the definition is very much like the primary alkyl bromides or iodides from last year. We can see here the alpha carbon, which has the functional group attached, is attached to 1 other carbon. That's primary, that's the definition. Over here, it's attached to 2 other carbons, and therefore it's secondary. You will be able to do things with this that you can't do with this, and vice versa, because of the different numbers of hydrogens attached. And tertiary will do totally different things, because again, here you don't have any hydrogens, you just have 3 carbon groups, and that's where this comes from. And let's get this right, it's tertiary, not second degree or primary. It is not 1 degree, it's primary. Make sure we understand the names. And so when we look at examples, we can start to understand that. On the left, at the bottom, is the base unit of phenol. We saw that last semester, we know a little bit about that already. And then on the right, we have some numbers. And those numbers, again, this is sort of foreshadowing 2 chapters coming up fairly quickly in the term. We have a phenol. And because the OH group is built into that name, phenol, it doesn't need a number. So again here, 4-chloro, 2-nitro. Why is the chloro before the nitro? Alphabetization. So the numbers here just go with the alphabetization. You don't put the 2 before the 4. They go where the alphabetization goes. And once you develop that, you're away. So I'm going to stop there. And I'm going to stop this, and hopefully I have something at the end of this.